In this video, we'll be writing equations for parallel and perpendicular lines. There are a few different ways of actually finding that equation. Today, we'll focus on the visual or the graphic way. So for instance, what if we have a line given by the equation y equals negative 4x minus 2? So let's graph this line first. We have a line. Let's see how it looks like. Using the slope-intercept form, we're starting at the y-intercept, negative 2. Then we'll look at the slope, negative 4 in the ratio, that would be negative 4 over 1. So I have a negative direction. It's always good to visualize your line first before you graph it. So going down to the right, we need the negative slope for negative sign. And then we have the ratio 4 over 1, I'm sorry. 4 over 1, the slope in the fraction. 1, 2, 3, 4 over 1, negative direction. Or I can go up. 1, 2, 3, 4, left 1, negative direction. So connecting the points, we have the line tilted in the negative way, and it is going through negative 2 on the y-axis. And I'm going to highlight it in yellow, just like on my paper in the notebook. This is my given line, so I'm going to even label it given. What I have to do is graph a perpendicular. There is a perpendicular. Perpendicular is going to be another line intersecting my given line at 90 degrees. So that word perpendicular is telling me that I have to graph a line intersecting my given line at 90 degrees. Let's see how that's going to look like. That line has to be in a certain place. So how do I know what place? It says we must go through point negative 4, 4. So graph a perpendicular through negative 4, 4. So I know that my line has to go through 1, 2, 3, 4 negative, 4, 1, 2, 3, 4 positive. To graph a perpendicular through negative 4, 4, it means that my line, first of all, has to cross the given line at 90 degrees exactly. And it has to go through point negative 4, 4. That's important. Negative 4, 4. How to make it exact? Let's see. Step 1. We trace the given line, so we did that. Then we plot the point negative 4, 4. We did that. Then, this is the important part. You have to reverse the slope. Reverse the slope to create an opposite reciprocal to trace the perpendicular line. So the given slope is negative 4 over 1. So this one was given slope, right? So what I'm going to do is reverse. In other words, to do a perpendicular, so this is the perpendicular symbol, I have to create opposite reciprocal. The word itself, opposite, says it has to be a positive, and then the reciprocal of the fraction. So you turn upside down the fraction 4 over 1 and create the opposite reciprocal slope 1 over 4. This is going to be the slope of my perpendicular line. Perpendicular is going to be a line crossing at 90 degrees exactly by using that opposite reciprocal slope. So here we go. We know that we have to go through point negative 4, 4. And we know now that we have to use the opposite reciprocal slope. So it's going to be 1 over 4. So from that point, I'm going to go 1 over 4, cross that y-axis. I can go again 1 over 4 and keep going using the same slope. Now check this out. Once I connect these points, the given line and the perpendicular of the blue line are crossing at exactly 90 degrees. How can I check that? I can measure that with a protractor, but if I don't have a protractor and I want to have a quick check, use a corner of any paper. So I'm using my sticky note, and the corner of a sticky note is 90 degrees, or corner of any paper that you have available lying around that is a rectangle or a sticky note like I am using right here, and use that intersection to see that you will be able to fit the corner of that paper into the intersection of the given and perpendicular line, and you'll see that it's exactly 90 degrees. If you're using even a ruler, that corner of a ruler will be another good tool for you to see if it fits exactly. It is a 90-degree intersection. So that is when you reached your goal in drawing a perpendicular correctly. You can always measure with a protractor. Now, this is the line that is crossing the given line at 90 degrees, and we have to write the equation for it. So now what do? To write the equation for that perpendicular, we have in slope-intercept form now the opposite reciprocal slope, positive 1/4, times x, and then we need this y-intercept. That's why we had to make sure that we go through to cross the y-axis. 1, 2, 3, 4, 5, plus 5. So the equation of your perpendicular line will be y equals 1/4 x plus 5. So step 4, write the equation of the perpendicular line, y equals 1/4 x plus 5. So let's see the steps again. If we have a given line, we trace that first. Then we see what kind of line we need to trace and through what point. So the point that we need to go through is what we need to plot. Plot point negative 4, 4. That was right here. Then, because we have to trace a perpendicular line, we will reverse the slope. In other words, opposite reciprocal. If my original line was going down, now I have to go up to cross it and use the upside down or reciprocal of the slope. Trace the line, identify the y-intercept, put those two together, the new slope, opposite reciprocal, 1/4 times x plus the y-intercept, 5. 1, 2, 3, 4, 5. So the equation of the perpendicular line will be y equals 1/4 x plus 5. What if we have the given line y equals negative 1/4 x plus 5, so let's graph that. Starting with the y-intercept, 1, 2, 3, 4, 5. And then I have the negative 1/4 slope, so I have to go a negative direction with a tilt of 1/4. So 1 rise, 4 run. 1 vertical, 4 horizontal, negative direction. So I can go down right or I can go up left. The direction will be negative for the given line. Color coding helps, and labeling is really important as well. because the more lines we have on the coordinate plane, the more labels we'll need or colors to identify which is which. So this time, for this given line, I have to graph a parallel. Parallel lines don't cross. Parallel lines never intersect. Parallel lines go side by side, never crossing. Well, if parallel lines have to go parallel, side by side, never crossing, they have to go same direction. Parallel lines will all line up following the same slope. They're all going to go down to the right, and they're all going to have the same tilt, so they're all going to have that negative 1/4 slope. So a parallel through point -8, -1. Okay, let's see where that is. 1, 2, 3, 4, 5, 6, 7, 8, down 1. Double check. 1, 2, 3, 4, 5, 6, 7, 8, down 1, -8, -1. That point needs to be used, and the line has to go parallel. So that means the line has to follow same exact slope. So first step, we trace the given line. We plot point -8, -1. Step 3, use the same slope to trace a parallel line. Why? Because the lines will have to go the same direction because they must be parallel and never cross. So they have to have the same slope. So we go down over 4. Is that enough? No, we need to identify that y-intercept because we need to write the equation for that parallel line. So we go down 1 over 4 again. Here we crossed the y-intercept, so good. But why not? Let's go down 1 over 4 and use multiple slope counts for consistency. And when you connect those points, you're going to have a nice, accurate line. This time I'm going to highlight it in orange because that's the color I used for the word parallel. So if I use my point, -8, -1, use the same slope. So if the given slope was -1/4, symbol parallel to vertical lines will be the same slope, -1/4. So the given slope and parallel slope will be the same. What do we need to write the equation of the parallel line? We need the slope-intercept form, y equals mx plus b. So y will be same slope, -1/4 x, and then the y-intercept from the graph is -3. So y equals -1/4 x minus 3 is the equation of the parallel line to the given line. So the given line had the equation y equals -1/4 x plus 5. The parallel line has the equation y equals -1/4 x minus 3. In the equation, we can see same slope, but then different y-intercept. Let's see another example. For instance, we have the given line y equals -1/3 x plus 4. Let's graph that. So starting at 4, 1, 2, 3, 4, we start at the y-intercept. Slope tells us go down to the right, -1/3. 1 down, 3 right, or 1 up, 3 left. Negative direction. Down right or up left. Negative direction. highlighted in yellow. Given line. This time I have to graph a perpendicular. That means 90-degree intersection through point -1, -1. -1, -1 is right here. So these directions are telling me that I have to trace a line that is going to cross the given line at 90 degrees. So remember that 90-degree intersection, the sticky note, this way, this way. So my line has to go through point -1, -1, crossing the given line at 90 degrees, perpendicular. So I trace the given line, I plot my point -1, -1. Now I have to use the opposite reciprocal slope. So reverse the given slope. The given slope was -1/3, so the line went down. Now to cross it, I have to go up. So to create that perpendicular, I have to reverse the sign and turn it upside down. So opposite reciprocal slope, +3/1. If the given line was going down with the slope of 1/3, the crossing or perpendicular at 90 degrees have to go opposite direction. So up and then reverse 3/1. Let's see what happens if we go up 3/1 from the given point that we have to make sure we go through. So that's why we start there. And the goal is to intersect that y-axis for the equation. And then I can go again up 3/1 for accuracy. Or from that given point, I can go down 3, left 1. Down left will still be positive direction. So my line again is crossing -1, -1. That's part of the direction, so it has to be included. And then once I connect it, before I highlight it, I can even check to make sure that my sticky note is fitting perfectly into that 90-degree intersection. Or as a quick tool, you can use your ruler to check. That could be really useful for you in the future, because sometimes, again, when it comes to multiple lines on the coordinate plane, it's going to be hard to identify which is which. So given, and then the perpendicular. Given line and perpendicular line are crossing at exactly 90 degrees. To write the equation of the perpendicular line in slope-intercept form, now we're using our opposite reciprocal slope, 3/1 multiplied by x, or just 3x. And then we need that y-intercept plus 2. Y equals mx plus b, the equation in slope-intercept form of the perpendicular line. Let's see another example. For the given line, 3/5 x, so y equals slope 3/5 in front of x, and then plus 3 y-intercept. Starting at the y-intercept, if you would like to give it a try, pause this video at this point. See if you can do it on your own, following the previous steps, and then play to check your answer. That's a good idea to challenge yourself or go along with me. So I'm going to graph this given line, starting with the y-intercept, and then I'll go positive direction, 3/5. Positive direction up to the right, 3 rise, 5 run. Given line, 3/5, positive. Or down left, 3/5. That is my given line. Now what do I have to do? Parallel or perpendicular? Let's see. Graph a perpendicular. Perpendicular is a 90-degree intersection through point -3, 2. -3, 2. So this point has to be used, -3, 2. So the perpendicular can go through any point on the coordinate plane. So to know a location, I have to know a point. So that point must be given in the directions. Otherwise, I don't have a point of reference. So I know now that I have to cross my given line at 90 degrees perpendicular and then write its equation. So I traced my line, I plot the point, now it's time to reverse the given slope. So in the original equation, the given line had positive 3/5 slope, and then to go across, instead of going up, now across, we have to go down. So perpendicular, we have to go down, and opposite reciprocal. So opposite sign, upside down, opposite reciprocal slope. That would be 5/3. So when we look at the original or given slope, we need to go the opposite direction to cross it exactly at 90 degrees. -5/3. So I have to go down 5/3, rise 5 across 3, vertical 5, horizontal 3, from the point that they gave us to go through in the problem. So that's where I'm going to start in that given point and then go 1, 2, 3, 4, 5/3 and across that y-axis. That is enough for my equation. If I can extend the same count for accuracy of tracing the line. Quick check with a ruler or a corner of a paper. All this intersection angles are at 90 degrees because when we cross two lines in 90-degree intersection, we have all four angles 90 degrees. Okay, so when we check, even sometimes you don't trust your eyes because it kind of looks tricky, put a piece of paper in there or a corner of the ruler and check to see, or measure with the protractor. To write the equation, we need that opposite reciprocal slope, which is -5/3, and the y-intercept, -3 of the perpendicular line. In slope-intercept form, y equals slope -5/3 x minus 3, the equation of the perpendicular line. Let's see another example. What if, some interesting stuff happening here. What if the given line is not in slope-intercept form? Well, then we have to transform it to slope-intercept form. So the given line, 3y equals x plus 2, has to be in slope-intercept form. So here all I have to do is just one step. Divide by 3, and that equation will be 1/3 x. And then I have a fractional y-intercept. I'll just leave it plus 2/3 and see what to do with that thing. Then I'll have to graph a parallel through point -6,5 and write its equation. Okay. So let's start at this y-intercept 2/3. Well, what is 2/3 of a unit? Okay, so if I was to start in 2/3, that means that I would take this unit, 1 square, divide it into 3 parts, so size it up, estimate, and just go like slightly above half. So if I was to split it into 3 parts, because it's thirds, and go up, choose 2 thirds. So 2 of those third pieces. So 2/3 is my point right here. If I was to divide 2 by 3, that's approximately 0.6, 0.7 if I round it up. So it's like 0.7 on the y-axis. And it's fine. It doesn't have to be always a whole number. Now, when you trace the slope 1/3, so now the slope is 1/3, now that we have it calculated, the number multiplied by x, I have to be very careful when I graph because I have to, 1 full unit is going to be from that 2/3 location to 1 2/3 location. So I'm using 1 unit and then you stay on that mark and go across 3 to go for that positive 1/3 slope. And then you can go again from that mark across and trace the line. So this is our given line so far. What we have to do is graph a parallel. Well, parallel is great. Parallels always have to have the same slope. Same slope because they have to go the same direction. They never cross and they will all have 1/3 slope. 1/3 slope will be the slope of each parallel line. So where does it go? We have to make sure it goes through -6, 5. So where's -6, 5 now? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Right here. Double check. -6, 5. So I have to use this point and I have to make sure that I trace a parallel. What do? Parallel lines have same exact slope. So use the same slope to trace a parallel line. 1/3 will be the slope of every parallel line traced to this given line. We only need one, and it has to be the one that goes through point -6, 5. So that way. What do? We use the same slope, 1/3. Not there yet. We have to cross that y-axis, 1/3. And now we are crossing it in the whole number, and you can extend some more for accuracy. So what would be the equation of the parallel line? Now we have everything we need. In slope-intercept form of the equation, y equals mx plus b, we need the slope, which is 1/3, times x, and then plus y-intercept 1, 2, 3, 4, 5, 6, 7, where the line is crossing the y-axis. So the equation of my parallel line is 1/3 x plus 7. You can pause the video and try example number 4. Challenge yourself or go along with me. For the given line, again, it is not given in slope-intercept form, so we need to find that slope. So in order to do that, we have to transform it to slope-intercept form. So I'm going to write it here, negative 2x plus 3y equals -3. And I'm going to start transforming it to slope-intercept form with the goal in mind, y alone equals mx plus b. So I need to add this 2x to the other side. Once I add my 2x, the terms 3y will equal, in slope-intercept form, I'm going to put the 2x first, and then -3. Then I'll divide by 3 in order to have the y alone and simplify the right side. So 2/3 remains my slope, and negative 3 divided by 3 will be negative 1, the y-intercept. So to graph my line now, which is given, transformed in slope-intercept form, I need to start at negative 1 and use 2/3 positive slope. So I have to go up to the right with a count of 2 by 3. So 2 up, 3 over, 2 up, 3 right, or 2 down, 3 left. 2 down, 3 left. That is the positive direction of the given line. So still working with that given line. So if the given equation is not in slope-intercept form, we would have to transform it to slope-intercept form first, and then trace the line. We need to graph a parallel to this line. So parallel means use the same slope, and we have to include 0.38. So 0.38 is 3 to the right, 1, 2, 3, 4, 5, 6, 7, 8. Here's my 0.38. Use the same slope to go parallel. So it's always good to visualize first. So place a pencil down or put your hand down to see that word parallel happening. Visualize it first. Make sure it goes through 0.38. Use the same slope. If the given slope is 2/3, the slope of a parallel line is exactly the same, 2/3, because they have to go same way, same direction, same orientation, same slope. So I'm using this 2/3 slope, so down left, cross the y-axis, down left, cross the x-axis. So it's either upright or down left. 2/3, went too far here a little bit. So 2/3, 2/3, 2/3, using multiple count for accuracy. The line goes up to the right, so it's positive. That same slope, we can visually see it's now parallel lines going through 1, 2, 3, 4, 5, 6 on the y-axis. Put that slope 2/3 in front of x and the y-intercept plus 6 to complete the equation in slope-intercept form of the parallel line y equals 2/3 x plus 6.